go to school spirit today. I've got a nice UV shirt on, back from 2015. So I'll probably be having a math week here soon, because y'all love math, right? It's your favorite subject? Okay, so we're going to finish 4.3 today. Now, there's two main types of logarithms that we're going to use in real life. One are called common logarithms, and the other one are called natural logarithms. Okay. Common logarithms are base 10. And natural logarithms are base E. Now, one of the nice things about base 10 logarithms, if I did the log of, say, 10,000, one of the nicest things about a nice number like that is all you have to do is count the zeros, because it's 10 to the fourth, right? Or the log of 100. If you don't put a base, you assume it's a base 10. So the log of 100 would be what, Maddie?
10
Or just 2.
or 2.
Yeah, 2. Log of 100 is 2. Okay. Now it doesn't work if you have, say, the log of 200. Don't just count zeros in that case. It's got to be something else. So I guess you can plug that in your calculator. What would that be? Who's got it? Give me about 4 decimals. Usually when we want you to use a calculator, go 4 decimals. I think Demi's got it.
2.301.
2.301, and so you would write that as a exponential equation as what?
Would it be 10 of 2.301 equals 200?
Equals approximately 200. Okay? All right. So natural logarithms are base E. They follow all the same logarithmic functions we've been using. If I have the ln of 8, the ln of e to the 8th power, you should be able to do that without your calculator, Andrew, and you would get ln of e to the 8th. 8, very good. Can you just pull that out front? And the ln of e is, no, it's not.
Wait, 1.
No, thank you. ln of e is 1 because it's the same base, right? How about the ln of 1 over e squared? Without your calculator, you should get what, James? On the phone, your friend Joey?
Is it -2?
-2? Why is it -2?
Because it would put it over, it would put it to a fraction.
Could you write that as not a fraction, James? You couldn't? You should be able to, though. You're going to spend more time in math lab, so you know how to write that without a fraction. How would you do that, Cameron?
Negative e squared.
Not negative e squared.
No.
E to the -2. So e to the -2, and then you can pull that out front, right? And then you do remember, James, the ln of e is 1. Very good. So 1 times -2 would be -2. Okay? So you need to practice, okay? Should get these like super quick. How about the ln of 5? Michael can do that one in his head. Okay. I was teasing. Who's got their calculator out? Lauren's got it. ln of 5 is?
1.609.
1.609. Everybody can do that in your head, right? Okay. But Michael, now that you know that, you could write that as an exponential equation as
e to the 1.609 equals 5.
equals approximately 5.
Yeah.
Okay? All right. Now, okay, so they've only got one problem in here, one example. F of x equals ln of 4 minus x squared. Okay? And I want you to find the domain. Now, I'm going to spend a little bit more time on this because I can almost guarantee 90% probability, let's say, that you're going to see a problem like this on the final exam. And I want you all to ace it.
Is that 14 or?
4. Sorry, those are parentheses. The ln of 4 minus x squared. I'll write it better. Ln of 4 minus x squared. And I want you to find the domain. So, Cameron, do you have any idea how you would do that in the back? No clue. Zach knows. No. Scary.
Would you factor in 4 minus x squared?
Factoring would not be the first thing that I would do.
No, it said 4 minus x squared equal to 0.
You would set 4 minus x squared equal to 0. Why would you do that?
Because if it ends up being 0, you can't take a log of 0. That's like the cutoff point.
Well, is 0 the only point?
Or negative. Anything's a 0. Unless
Okay,
it's 0.
so we don't want to put an equals here.
Yeah, it has to be greater than 0.
We want whatever's in the parentheses to be greater than 0, right? Now, before we finish this problem, because I know that in my last class I really struggled with this, and I have a feeling that many of you are struggling with much more than Michael. Okay? Now, if you were to graph y equals the ln of x, let's talk about that for a minute. Nathan, you remember how to graph that?
Graphing calculator.
Yeah, without a graphing calculator, you have graphed that how?
Did you do this last time?
Yeah, we did it actually at the beginning of class, but it wasn't recorded.
It was last time. I missed that one.
What's that?
I missed last.
Yeah, but we did it at the beginning of today's class. In
Oh.
fact, Lauren asked an extremely similar problem.
It's an exponential curve, right?
It's not an exponential curve, it's a logarithmic curve. Okay? So how do you graph that? Don't remember? You want to phone your friend Hallie?
Yes.
Hallie, how do you do that?
Will the asymptote be at x equals 0?
Can the asymptote of x equals 0?
Then your important point will point to
Your important point. Now, by the way, in my other class, you called that the magic point. You like that better? Does that sound better? It's not really magical, though. It's catchier, though. Okay, the important point, the magic point, goes there, and then
you have the curve.
you're going to have a curve that goes up like this. Okay, now, when you look at this, especially with the nice graph here, the domain, we'll go back to Nathan since he got bailed out. The domain's really easy when you're looking at this curve, correct?
Yeah, that's just anything above 0, right?
Yeah, so x has to be greater than 0. Can it equal 0?
No,
No, because?
it's logarithmic.
Because it's logarithmic, and what do I have as 0?
I don't know how to put it into words.
What?
I don't know how to put it into words.
What's that dotted line?
Oh, that's good.
That's an asymptote. I have an asymptote equals 0. So the idea here is, and just for fun, if I asked you what the ln of -3 was, you would say,
That's impossible.
well, impossible is not what quite I was looking for.
Undefined.
Undefined. Undefined. Okay, do not write error. Seen that before. Okay, it's undefined. Because it's not in the domain, there's nothing on this side of I can't take the log of a negative number. I can't even take the log of 0, right? The log of 0 is undefined. I got an asymptote in the way. Okay? All right. So the reason why I'm mentioning this is because, remember, you cannot take the log of a negative or 0 number. So whatever's in here must be greater than 0, as I said here. Okay? So we're going to apply that same thing back to our original problem. Whatever is inside your parentheses must be greater than 0. Okay? Now, okay, I'm not asking you to graph the logarithmic function, but I will ask you to graph what does this look like if you were to graph just this as a function? Javier? What does that look like? It would be a parabola facing down, and where's the vertex? If x is 0, where's the vertex? 4. Okay? 1, 2, 3, 4. Now, who was it that mentioned factoring before? Okay, so Joey now. Okay? Now we know this is a downward facing parabola, right? Now I need to figure out what those 2 points are. How would I find those?
You factor?
I could factor in this case. Now I am going to set it equal to 0 because I need to figure out what those points are. But can this equal 0? No. But in order to find out what these points are, I'm going to set that equal to 0, and I would factor it into x.
Would be,
Sorry, the x is in the wrong place, isn't it? I'm used to it being there. X and x.
would be a 1 and a 3? Or, no, 2 would be 2 and 2.
2 and 2, right?
Yeah.
And the sign would be
Plus.
plus and minus. So x is going to equal 2, x equals 2, or x equals negative 2, correct? Okay? Right, we're right through it. That's nice. Now, the question is, okay, let's go back to the domain. We're talking about the domain of this entire function. And it only will take it if it's a positive number. So what part of the curve is positive? The top part of the curve, right? So all of these can be used, these cannot be used. Okay? So going back to here, what is the domain? Cameron?
2.
The domain is 2? So x can equal 2? Is that what you're saying?
No, x is less than 2.
X has to be less than 2. Okay, so it's got to be less than 2. And it's also got to be greater than negative 2. That's your domain. You can only take these values here because that's where it's positive. Values beyond that are negative. And I can't take the log of a negative number. Okay? So if you were to write that in interval notation, Eunice, how would you write this in interval notation?
Negative 2, 2.
Parentheses on both sides?
Yeah.
And what else are you missing? How did you forget? You haven't missed this enough. You've only gotten half credit. What's you forgetting? X is an element of, right? X is an element of, okay? You'll never forget that again, Eunice. Okay? All right, does that make sense? Oh, you guys didn't tell me I was off camera. All right. Now, Here's what I'm concerned about. I only gave you 4 domain problems. And I didn't even give you the hardest ones. So I'm going to do the hardest ones today that I didn't give you. But one of these 6 problems will, I guarantee, be on the quiz tomorrow. Okay? Because I want you guys to be really good at finding domains, especially on logarithmic functions. And I want you to ace my test, and I want you to ace my final. Okay? So don't be missing these problems. Okay? Or I'll have to put them on every test from now on until you get it right. How many problems do we have on the last 2 tests that are going to keep coming back? At least 2, right? All right, so let's talk about this one here. Let's go over, let's say this. This is number 77 in the homework, although I didn't assign it. H of x equals the ln of x plus the ln of 2 minus x. I'm going to open it up to everybody, and I'm going to say, do you have any idea how to find a domain? You got an idea? Warren, do you have an idea? Does the other Warren twin have an idea? Joey?
Do you want to solve individually first? Or
Not solve, but let's take this into pieces, right? Okay, let's pretend that's the only part of the function for now. Okay? What's the domain, Daniel? The domain of just this piece.
Greater than 0.
That's only half correct.
Well, x is an element of
X greater than 0. I just wanted the x. That's all I was asking for.
oh,
Okay? Don't forget the x. Okay? Now let's talk about this piece for a minute. What would be the domain of that, Rory?
X can equals 2, negative 2, not 2.
Oh.
0.
Okay, so you're treating that like an equals, right? But 2 is not the only thing. Remember, this piece here, 2 minus x, must be positive, right? And it can't be 0. So what should I put here? What would symbolize positive?
Greater than.
Greater than. 2 minus x must be greater than, no, 0. Okay? Now you can solve that. How do you solve that?
Make it an equal sign.
You don't have to make it an equal sign, but you can just add x, right? You can treat it like it's an equal sign, even though it's not an equal sign. So 2 has to be less than x, or better said, x has to be less than 2. Okay? So treat these 2 things as an and. X has to be greater than 0, and x has to be less than 2. How could I write that? Cameron?
X is an element of 0 to 2.
X is an element of 0 to 2, and those are both round, correct? Okay? Or I could have just said x is in between 0 and 2. I would take that. Okay? This is perfectly fine. X is greater than 0, x is less than 2. Okay? Does that make sense? All right, now what if we did number 78? Let's see how good you guys are on this one. H of x equals the square root of x minus 2 minus log base 5 of 10 minus x. Okay. Tyler, what do you think? I want you to find the domain.
so on the right side can be x times 10.
X cannot equal 10. Not just 10. There's other numbers it can't be.
Has to be x has to be greater.
So we're concentrating on the parentheses, right? So 10 minus x
Has to be greater than 0.
has to be greater than 0, and so when you solve that,
X has to be less than,
plus x, x, plus x, x is less than
less than 10.
10. Okay, so that's that piece.
And
What about this piece?
then we decide X has to be greater than 2.
So we only care about the insert side here, right? 2 is not the only one, though.
Yeah.
So x minus 2 must be,
Greater than 0.
can it be 0?
Yeah.
In this piece, it could be 0, right? You can take the square to 0, right?
Yeah.
So it could be greater than or equal to 0. So,
X is greater than 2.
so x, so add 2, x is greater than or equal to 2. Now, I'm going to put an and here. We want both of those conditions to be correct for the entire function. So, Cameron in the back, how could you write this so that both conditions are true?
Ten is greater than x, which is greater than or equal to 2.
So x is going to be greater than 2 and less than 10. Right? Does that make sense? Okay. And then Lauren, I could tell you wanted to put that in exponential, or not exponential notation, in integral notation. Okay? X is now in the bracket. Can't hear you. 2 comma 10 parenthesis. You guys agree with her? Who disagrees with her? Who's still sleeping? Don't raise your hand if you're still sleeping. Okay, I thought you were all asleep. Yes, either answer is correct. Okay? Even Lauren, I just picked on her, she's still sleeping. Okay? Does that make sense? Are you gonna ace this on my quiz tomorrow, Javier?
Yeah.
Okay, I was sort of confident. Okay? We still got 5 minutes left. Part of me wants to work on the next section, but we haven't time my last class. So I'm gonna be nice, and we're gonna let you go 5 minutes early. Okay, keep you guys in the same spot. So quiz is on the rest of 4.3. And hopefully you guys can graph these awesomely. Do you have any questions about graphing these? You guys are feeling good? Think so? Okay. All right, see y'all tomorrow.
Oh, actually, that's a question.
Turn this off.
Is there a difference between the LM graph and